session. So this side Priya Bhatia, and today we'll discuss about the implementation of KNN algorithm that we have discussed in our previous session. So I hope that you all remember that we have discussed in our previous session regarding the major, you can say, mathematical intuition behind KNN regression or KNN classification problem. As you might be aware of that KNN can be useful for both of the problems, whether it be a classification problem or it be a regression kind of problem. And those points we covered up pretty well. So if there is someone who haven't watched the previous video and directly jumping into this video might get confused or might not able to collect everything from this particular video, so I will just request everyone, this is my humble request, to just watch the previous session before, because there I have explained the mathematical intuition and idea behind the KNN. In today's session, the major agenda is, let me try to discuss about the problem definition first, and then we will go to the coding part step by step. So what we will do is that I am picking up a data set which is of stock prediction. So there is stocks data set which I am predicting. I want to predict. So I hope that everyone is aware of the stocks, right? So here, what I'm using is the quandl to get the data set related to the stock market. And after that, what I want is that there are two things which I am doing, okay, in my code, which I will show you just in a few seconds. So here, what we want to do is that, first of all, we want to implement KNN, right? So you will see a KNN implementation. And now, as we know that KNN is basically used for both of the kind of problems. So I have converted the same data set into a classification kind of problem as well as into a regression kind of problem. How? That you guys will get to know when we're talking about classification kind of problem. So what I did is that there is one feature inside our data which is a clause, so basically this feature is basically demonstrating that this feature is something which is clause, which is basically the target value, or the, you can say, yeah, target variable that you can say, which we picked up. So let me show you the data set first, and then I'll try to show you the problem statement which we will solve it here. Okay, so now here these are the predefined libraries which I have imported: pandas, numpy, matplot, lib.pyplot, and I hope that everyone is aware about these kind of libraries. So now what I'm doing is that I'm just importing this quandl library. This particular, if someone doesn't know, this is a very famous website which is basically used to extract the data which is related to economics or financial background. So what I will do is that, first of all, I will just import this particular library called quandl, so that I am able to use the data set from this particular library. So basically what I'm doing is that I'm basically using a historical data of stocks, and mainly I'm using a stock of Tata Global. Okay, so this, I'm just using a get function to get that data. So once I will be able to get the data, if I suppose want to see maybe top 10 records, so what you can do is that you can just run the code, and just, if by default, if you are not mentioning anything in this, it will display the top 5 records of your data set. If you're mentioning 10, so if you will be able to see, now this is basically the data set that we have. So here, if you will see, date is there, right? And the features that we have is open, high, low, last, close, total trade quantity, and the turnover of the stock that we have. So here, for every particular date, we are having these 4 or 5 features that you can see, right? Now I want to predict maybe that what is the prediction of this close value, what is the prediction of this close value which I have. Okay, this is one thing. Or maybe if I want to talk about, so that particular kind of problem is something which we can say is a regression problem. But suppose I want to predict that tomorrow whether I should buy or sell a stock. Means, if suppose the prediction of the next day of the stock is higher then the current date. So what I will do is that I will maybe buy the stock. If suppose the stock price of today date is lesser, and I am sure, or I am predicting, my model will be able to predict to me that okay, it will go up by tomorrow. So in that particular scenario, I will prefer to buy the stock, right? I will prefer to buy the stock, and I am representing this buy value with +1 class. And if suppose my model will be able to give me an intuition that in future my value will go down, the stock value will go down, then it's better to sell the stock. I hope that now you will be able to get an intuition. And this selling part I'm representing maybe by a -1. So one problem is kind of regression problem, where I want to predict the value of the close. Another problem is a kind of classification problem, which is basically helping me to define that whether should I go for buying a stock or whether should I go for selling the stock. I hope that the problem statement is pretty much clear to everyone. Given a data set, what I want is that the very first problem is that I want to predict the close value. Another thing is that I want to predict that whether I should buy or sell the stock. The class which I'm using to represent the buying the stock is +1, and the class which I'm using to selling the stock is -1. So these are the two tasks which I want my model to do, 1 and 2. So these are the two tasks which I want my model to majorly do. I hope that this part is pretty much understandable to everyone. So for this particular thing, what I'm implementing is KNN algorithm as of now, and I want to see the performance. This is the source of my data set. So this is where I am extracting the features. I am extracting the whole, you can say, data set from the Quandl website. Okay, let's get started with this. Now I want to see I want to sense the close variable which I want to predict. So if I will run this code, fixed size is basically used to increase the figure size, right? So that's the major purpose I have used it here. If you're not using and just directly using PLT or figure, maybe the size of your figure will be too small. Now, what should be the predictors I picked up? Now, what I did at here is that in order to demonstrate to you, I took something called open minus close and high minus low, which is basically a combination of the difference between the open and close, which is basically stored in open minus close. And when I'm talking about high minus low, it's a subtraction of the data which is present at high and low. So basically, these are the, I'm not taking lot of features, I'm just taking these two features. So these are the, you can say, input features to predict whether I buy or whether customer should buy or sell the stock. Okay. So in order to do the classification task of the same, what I am doing is that I am taking the difference of open and close and high and low as a input feature, and I am dropping the null values whichever I have. Okay. So now here if you will see, this is the data that we have where there is open minus close and high minus low. Difference is there. What is the basically target variable that we have? So this is the very first task where what we are applying is a classification problem, which I have explained already on your blackboard. So this is a classification problem where I want to know whether I should buy or sell the stock, whether I should buy or sell the stock. So this is a classification problem. And here when I'm saying buy, so I am representing that with class +1. And when I'm saying sell, so I am representing that class with -1. Okay. Now here if you will see, these are the input features that we have. Now this is the target variable. So here if you will see, what I'm saying is that if data close dot shift -1, try to understand this part now very much carefully. What we did here, what is the shift function doing? Shift function basically shifts the column up or down. Here if I'm saying data close dot shift minus 1, what it is doing is that it is collecting the close value of the next date. And what I am saying is that if that particular value is greater as comparable to the current value, means the today's date, if the value of next date is greater than the value of current date, means if the value of next close date is greater than the current date close value, then what does that mean? It means that next day the stock will become expensive. At that point of time, I will want the label as 1. Otherwise, in else condition, I want the label as -1. I hope you get my intuition pretty well. What I'm saying is that if I suppose I purchase the stock today and the price of that stock is maybe 500. Now, if I have a historical data, so I have to use that data to make a sense of the prediction of the future data set. So now what I'm saying is that with that dot shift -1 thing, I am trying to see the next date, which is the tomorrow date, because that's the historical data which I have. So I can see the next date data as well. What is the next date close value? If suppose today I have the stock with 500 and the next date the price is 600, it means it increased. At that point of time, I am labeling it as +1. Otherwise, I will labeling it as -1. I hope that I am making this point pretty much clear. And this is the value which I am having. Now, if you will see in the y, I have either +1 or -1. Now, what we can do is that we can split our data into x and y. We have x and y, sorry. We want to split our data into training and testing. So for that, we can call our library called model underscore selection, and we can import train test split. Here, if you will see, the test size will be 25%, which we can use. By default, it is 20%, and you can apply the even random state also. So what is the feature? What is the major, you can say, purpose of the random state? If suppose I will write random state as 44, at that point of time, the code that you are doing and the code that I am doing, the training and test set will become same. That is the only purpose of the random state. It is the only purpose of the random state. So here, let me try to see random underscore state will be there, might be. Yes. So here, if you will see, if suppose I am doing a random state, in that particular case, suppose you also mentioned 44. And then if you will try to see what is the training set you have, and if I want to see what is the training set I have, that will be same. If suppose you're not applying that particular feature called random state, then it might be the case that your training and my training test set will be different. That's the only purpose. Now, I hope that this part is pretty much clear to everyone that what this function is doing. It is basically splitting our data into two parts, training and testing. After that, try to now just focus on this particular portion. What I'm doing is that I'm just importing the kn dot classifier, kn dot neighbor, which is basically importing the k neighbors classifier. Here we are applying a grid search CV. What this basically grid search CV is doing, if you guys remember in the previous session also, I talk about the value of k. The value of k, which is nothing but the minimum number of neighbors which I have to see whenever I am predicting some data, right? Now the question is that what should be the optimal value of k I should pick up? I don't know. It depends on the dataset that you have. In order to find out the optimal or the good value of k, we can use a approach called grid search CV. Grid search CV. So here, this k value is a hyperparameter. Hyperparameter, which basically used to represent the number of neighbors that we have. Now, what should be the number of neighbors I will pick up? I remember in the previous session I said the value of k is 3, but how do I know? It depends on the dataset that we have. So here if you will see, the dataset that we have, I am just telling to my data that number of neighbors can vary from 2 to 50. Take it, see the dataset and try to see which value will better suited for me, for my KNN classifier. And then I am applying the grid search CV on the top of that. And now I am fitting my model on the training data by applying model.fit. Finally, I am able to get the accuracy for the training and the test data, and I'm printing that particular accuracy for the same. So here, if I will run this particular code, so you will be able to get that the training data accuracy is 68% and your test data accuracy is nothing but 51%. So your model is predicting on X train, if you will see, that you will be able to get as a train accuracy, and on X test if you will predict the value which will be your test accuracy. So the value is either +1 or it will be -1. Okay, okay. So this is the thing that is a classification problem. I want to show you one more thing here. Let me try to show you the output, right? How it look like. So let me try to create one data frame um, which contains predictions, which will contain maybe actual and predicted data. Okay, so let me try to create a data frame. So pd.data frame. Here, what I will create is that I'll try to take a dictionary where the key is, you can say, the actual class, which is nothing but, I will say, the y test that I have, and then I want to have a predicted class, which is nothing but the score, which maybe I can store it as predictions for a classification problem, which is nothing but is equals to model dot, you can say, predict, and here the value of X test. So whatsoever the predictions I am getting here, I want to store it here. Let's try to run this, and let me try to show you one thing now. Actual predicted data dot head top 10 record, suppose I want to see. So here now you will be easily able to see or make an inference that this is your actual class, means your actual data says that you should supposed to sell the stock, but your predicted class says you should buy it. So this is a wrong classification. But here if you will see, it's correct. Here if you will see, it's again wrong. Here if you will see, it's correct. It's correct. It's correct. So somewhere there is an error, somewhere it's not. That's why the overall accuracy you can see is little bit in the average mode. The test accuracy, if I will specifically define, as 0.51. But now at least you guys will be able to make an inference that how basically Canaan classifier will work. What is the major purpose, how it is solving a problem, right? I hope that this part is pretty much clear to everyone. Now the question came is that it is not able to give that much accuracy. So in future we will try to see more different kinds of model, like a random forest, like LSTM, which is you will see that it might predict a better predictions as comparable to all these algorithms that we have learning so far. But because I have illustrated only about the Canaan, that's why in today's session I want to just discuss about this Canaan algorithm a lot. And I want to just show you that how basically this Canaan classifier will work in order to solve a classification kind of problem. And for that illustration, I just picked up a data set of stock prices, where my task in a very first note is to predict that whether I should buy a stock or I should sell it. Now, how I am converting those labels from +1 or -1, that I illustrated you here itself. And I hope that this point is also pretty much clear to everyone. Now, suppose the same thing I want to do, but now I want to implement a regression kind of task. I want to solve a regression problem by nothing but Canaan only. I want to demonstrate you the regression problem as well. So instead of saying buying or selling, which is a classification problem, I want to see that what should be the predicted value of close. As of now, because my features are not well suitable for this problem, because I have already used that close variable already, but still I just want to demonstrate you that how basically this Canaan regressor will work. I'm just using those features as it is, right? But Usually, we supposed to use a different kind of features so that we will be able to implement the KNN as a regressive problem. But here, because I want to show you both of the things in one go, that's why I am using the same X features that I have used in the previous problem itself. I am just changing the value of Y in order to show you the regression problem for KNN. So here, if you will see, the Y value which I was having is the data close. But there in classification problem, I was having a +1 or -1. I hope you are able to make a difference now. What is the difference between a classification and regression problem? Now here, if you will see, the test size which I picked up is this. Let me take a random state here also. Maybe the random state is maybe 44 again. And here again I am applying the grid search CV. Now I hope the purpose of grid search CV is also clear to everyone. To optimally quantify the value of K for any kind of hyperparameter, wherever we don't know what should be the value of the constant which I should pick up, I'll go for this kind of approach called grid search CV. And then we're fitting a model, we're calculating the predictions. And then if you will see, in these are the values which I am getting as a output predicted value. So here this is a kind of problem which you can say is a regression kind of problem. In order to see the RMSE score for the same, what is RMS? It's nothing but root mean square error. So there's a square root of whatsoever be the value you are getting, which is a Y test minus the Y predict whole square, and then square root of that. This is RMSE. So this is quite huge because of that particular input feature which we are picking up. If you will pick up the other features, it might be the case that you will definitely get a very lower RMSE. So what we want is that we want a low root mean square error, we want a low MSE, which is a mean square error, or we want a low MAE, which is a mean absolute error. This is what we want. Okay, now if suppose I want to see the actual and the predicted class, so that also I can see it very much beautifully, that this is the actual close value, but my model is predicting this value as the close value. So this is how basically with the help of KNN you can implement either a regression kind of problem or a classification kind of problem. It depends what kind of data set is given to you. It depends what is the problem statement you have, whether in that particular problem statement, firstly you have to see whether it's a classification based or it's a regression based. If it's a classification based, try to first of all do the EDA task properly. Try to see whether there are null values or not, right? I'll try to prepare one specific session whole on EDA, because in EDA there are so many things which we have to see, because EDA part is really important before data modeling. Here my main concern is to show you that how basically KNN is working, and that's what I showed you here. But here I didn't demonstrate you very properly about the EDA task, where how basically the detection of outliers will take place, how basically we can remove the null values, or how basically we can impute the null values. Those things maybe we will discuss in the future sessions. But as of now, I hope that the agenda of today's session is pretty much clear to everyone, where we have basically discussed that how basically we can apply the KNN classifier or KNN regressor on top of any kind of dataset that we have. Okay, so with this I would like to end this particular session. See you soon in the next upcoming session, where now I'll talk about a new other topic where we will discuss some other things, and I hope that you guys are enjoying a session a lot and will be able to gain insightful sights from them. If you guys have any sort of doubt, please do let me know in the comment section. I'll try to rectify it as soon as possible. Happy learning to all. Bye bye everyone. See you soon in the next upcoming session.